Good everyone. Today we are moving to chemistry practical analysis. So let me start with the quantitative analysis. Quantitative analysis, which is titration. So in this titration, I will not waste my time. I will just want to explain to you how you can form your table when practical, in alternative to practical. In this, so now today I want to assume my theta value is 12.40 centimeter cube. I want to assume my theta value is 12.0 centimeter, 12.40. And if you are a student, make sure you yield to the instruction uh, by your center. So don't use anything you see online in the hall. You have to work based on your lab. So this is just for alternative to practical on how to form table. When you are given data value in our analysis, how do you form your table of value? So the table of value is very simple in the sense that you can have your rough theta, the first, the second, and the third. Then you have your final readings, the initial, and the volume used. You can make all your initial to start from 0.000.000.000.00. You can manage it that way. Although due to this analysis 12.4, it is not practicable to start with 12.00. You can use a burette throughout the analysis, but let's start with this rough sketch. In this rough sketch, I want to get 12.40. So in my rough reading, I can still have 12.90. It is acceptable, whereby the volume used will be 12.90. Now starting with my first, second and third data, to prove perfection, there is no penalty if you use 12.40, 12.40 and 12.40 throughout, arriving at 12.40, 12.40 and 12.40. So here, if you calculate the average of these values, you will see that your theta value will be exactly 12.40. Many students has been fixed to this system of 12 point. If you want to arrive at 12.40, they tell you to use 12.50, 12.30, 12.40. If this is what you are used with, you will later discover that all of you in your center, this is what all the students later did, which is not, it is not actually okay. Even if the theta value is to get 12.40, it is not compulsory that you get this 12.40. You can still get 12.45, 12.43. So if you make your first theta to be 12.50, another one 12.50, another one 12.40, this is still okay. You can add 12.5, 12.5, 12.4 and divide it by 3. The answer will be 12.4 something. You are still correct. You can still use it that way. Do you understand? So if I want to use this 3 now, it means so I can decide to start the rough with 12.00, the final here 12.90, and the volume used 12.90. This 12.90 will be the initial year if you are working on basic analysis. If this 12.90 is the initial reading year, then your volume that you want to use there, which is 12.50, you add it up with this, then you have 25.40. Good. You can still use this 25.40 as the initial for the next one because you have 50 cm cube of volume. So if you are getting precise data, in precise data you should be expecting something about 12 point something again. So which means you still have about 24.60 cm cube in your burette. So you can make your initial for the next titration to be 25.4. So making your second theta to be 12.50, then adding it up with this, so you can have this to be what? 37.90. Good. This 37.90, you can still risk it. But the best thing, fill it up and start with 0.00 again. You want to get this to be 12.40. Then, if you add this, you have 12.40. Now you are arriving at this theory. So you are picking this theory to get your average theta value. So your average theta value now will now be 12.5 plus 12.5 plus what? 12.4 all over 3. Then you do this calculator, you get the answer. Answer will be 12.4 something something. The value you have, use it. So you will still be getting the same thing. You don't copy yourself in practical. Use your own value, but your value must be precise. There must be precision. Even precision sometimes is better than accuracy. Because if we are expected to get 12.40 cm3 as the theta value, you can, if in your own hall you are getting 12.90, if precisely in your hall you are having 12.9, 12.92, 12.93, anyone that go with this may be wrong due to the value you got in your own center. Make sure you check for precision, that all of you in that lab you are getting very close value, even if it is not as accurate as your teacher. That is that on quantitative analysis. Then under this quantitative analysis, if you want to know more about the calculation, you are a student, prepare, go to your series. If you have any question pertaining to this quantitative analysis, we cannot here solve all the questions related to quantitative analysis. If you have any question that is not clear to you under this quantitative analysis based on Waec practice, NECO practice, drop it in comment section. Give me direct message. And don't forget to subscribe to this channel before you continue watching the video. All right, thank you. Let's go to the qualitative analysis. All right, to the second part of the analysis, qualitative analysis. This is SWOT analysis, and this is the most simplest part of the work. In SWOT analysis, now you want to test for the presence of lead triazocarbonate 4 and starch. Lead triazocarbonate 4 and starch. To know this of a cell, the first thing, you are dissolving this in water. When you dissolve this mixture in water, so the number one, you have C plus water. So when you add C, okay, this is your number one. So in the text, you have C plus water. Then what do we observe? Already you must know that lead triazocarbonate 4 is insoluble salt. Starch is always insoluble. Starch will never dissolve in water. So you say the mixture is undissolved. So when the mixture is undissolved, what is the inference? If it is stated in the question that C is a mixture, if it is not stated as a mixture, just say that C is insoluble salt. Or if it is already given that it's a mixture, then you say C is mixture of insoluble salt. Is mixture of insoluble substances. As defined in the question. If they already tell you that C is mixture of salt, then you say insoluble salt, substance, insoluble substances. Now, what's the next thing? Already you know that testing for lead. Let's start by identifying the cation, the lead. How do we test for cation? You can ask to filter. So when you filter, then you are testing on the filtrate. So you know, little amount of these lead carbonate will dissolve. That is, you have the effect in the filtrate, and you may not ask to filter, you may just ask to text directly for. Now, how do we test for lead? Remember that in testing for lead, we use, now if you have to add aqueous sodium hydroxide plus a portion of C, so you can say C portion, or you can write just C. What do we expect? We expect to have white chalky precipitate. White chalky precipitate. And whenever we have white chalky precipitate in the reaction of sodium hydroxide with a salt, what is our inference? What can we infer? We can infer that magnesium stroke calcium 2 plus or lead 2 plus is present. Now, although we have zinc, we have aluminium with very similar characteristics, but zinc and aluminium will only give gelatinous white precipitate. But once we have chalky white precipitate, on adding this in drop, Then in excess plus excess sodium hydroxide. So when you add excess sodium hydroxide to that, you are expected to have the precipitates dissolve. So when precipitate dissolve, it means there is formation of complex lead uh, ion. You know, complex ion is always soluble. So for the precipitate to dissolve, then we say lead 2 plus is confirmed. Lead 2 plus is confirmed. So when you confirm how this lead 2 plus, that is that. Although we can also use ACl to confirm lead 2 salt. Adding ACl with anything that contain lead, ACl plus C, we also give white chalky precipitate. Giving white chalky precipitate is also confirming lead. It means lead 2 plus is definitely confirmed. Now, after confirming the cation, now let's go to the carbonate. How do we confirm carbonate? Carbonate is confirmed by adding barium chloride. We use barium chloride aqueous solution plus that solution C, we give white precipitate. Also white precipitate. So when you see white precipitate, what is our inference? What are we infer? We infer that SO4 2 minus, SO3 2 minus, or CO3 2 minus is present. Continue this. When we had barium chloride plus that salt, white precipitate, then we say SO4 2 minus sulfate, triosulfate 4, and triazocarbonate 4 is present. Now, adding SS plus ACl. SS plus ACl. If the precipitate dissolve, then SO3 CO3 is present. If the precipitate remain undissolved, then SO4 is present. Now, because we are working directly to this CO3, so we say under the observation, the precipitate dissolve. So then we go back to CO3 2 minus, or SO3 2 minus is present. Is present. Now, adding the ACl, something must be observed. Plus effervescent of colorless gas, odorless gas, which turns lime water milky. Which turns lime water milky. Now we have already know that the gas is carbon 4 oxide from CO3 2 minus. Therefore, CO3 2 minus is confirmed. Is confirmed. It's confirmed. Now then the last part. Now we have test for the lead triazocarbonate 4. The last part is to test for starch. And how do we test for starch? We add C plus iodine solution. And you must know, you must be familiar with this if you're actually a student preparing for exam, or SS1, SS3 student. You must know the reaction of iodine with starch. When starch reacts with iodine, it turns blue-black. The iodine solution turns blue-black. Then we say starch is confirmed. Starch is confirmed. You can see now, if there is anything strange asked, you are not to memorize this or write this into the hall. That is very bad. Don't engage in sports. What you expect from you is you want to test for lead, triazocarbonate, and starch. How do we test for this? You dissolve. After dissolving, the basic reagent used for lead, sodium hydroxide. In drop, in excess. In drop, you have magnesium 2 plus, calcium 2 plus, or lead. Then if it's in excess, it's dissolved. It means complex ion is formed. That is all lead 2 plus. Now after this, Number one is titration. Number two is salt analysis. Your number three will be based on your theoretical understanding of chemistry. If you understand chemistry, some theoretical, practical. The common one they do ask, they ask our delivery of gas, the downward delivery of gas, upward distribution of air. We have many principles like that. Can ask to mention some. Okay, let me ask some basic question. Mention some gases that can be used for fountain experiments. That is the soluble gases. Mention the following, about five gases that can be produced by combustion. Mention gases that when produced in the lab has to be in fused coupled experiment, that is, that will not be exposed. Mention ways of taking care of sodium in the laboratory. Draw an experiment to produce a particular reagent. It can be asked simple calculations sometimes, but it's always simple. The basis of the major issue in this practical is this qualitative and quantitative analysis. The quantitative analysis require you to be serious and go to your series, see how questions are asked, and that basic principle of the I know you should remember this basic formula that you use then CAVA over CB, phi is equals to NA over MB. So whenever you are using this formula in your Waec exam, please don't forget to define your symbol. Don't assume they should know the symbol. No, before you write this, make sure you define your symbol. You have space. You have a lot of space in your book. So what you have to do is say Ca is equal to what? Concentration of A. If you are given in your question that A, don't just say acid. Concentration of H2SO4, if it is stated Va, volume of the acid used, Cb, concentration of B, then make sure you state the unit in mole per dm cube, in Cn cube, number of mole of acid, number of mole of base, before you now use it in formula. Please take note of those facts and take note of the units. Thank you. Please don't forget to subscribe, like, comment where necessary. Any question that you have, just drop it in comment section. Thanks for watching.